Consciousness emerges through a strict mathematical and geometric mechanism. A purely physical universe requires a rigorous structural framework before locating a subjective observer. Standard neurochemistry approaches the hard problem of consciousness by analyzing synapses and neurotransmitters. Yet mapping the biology of the brain fails to explain how physical matter constructs an internal subjective experience. The emergence of a conscious mind is not a biological accident. It requires the precise calculation of reference frames and dimensional geometry. To operate within physical reality, a system must actively construct and maintain a reproducible, high-dimensional mental space. The mechanism forcing this self-awareness into existence is the I operator. The I operator is a specific algebraic function that rotates a purely real scalar number into an imaginary plane. Subjectivity occurs when the universe executes this mathematical U-turn to observe its own existence. Cognitive science typically maps human awareness using Euclidean geometry, relying on biological markers like O'Keeffe's place cells. Place cells are specific neurons in the hippocampus that fire when an animal enters a distinct location. This animated diagram illustrates a standard Euclidean Cartesian grid. Models relying on this architecture assume the brain represents spatial data on a flat, passive plane. A flat grid maps external coordinates, but it completely lacks the capacity to represent internal perspective, self-reflection, or the complex curvature of lived experience. The necessity of an internally controlled, curved spatial framework traces back to the philosopher Immanuel Kant. He proposed the existence of an innate space generated by the mind itself. External physical space is rigid and absolute. An internal mental space must be actively generated and continuously updated to frame reality for an observer. Because a Euclidean grid cannot mathematically define a subjective point of view, cognitive models must shift to non-Euclidean geometry to accurately map the mind. To replace the Euclidean baseline, we apply the R3 immersion model. R3 is a mathematical framework representing a three-dimensional real coordinate space. Here we see an animated representation of this architecture, a three-dimensional Riemannian manifold. A Riemannian manifold is a smooth geometric space equipped with a metric that allows for the precise measurement of angles and continuous curve lengths. This structure differs entirely from the Minkowski spacetime metric, which maps physical relativity. As the overlay shows, Minkowski spacetime uses a negative time signature of minus, plus, plus, plus. The Riemannian metric is strictly positive. By treating all dimensions positively, the metric operates similarly to standard 3D space, but with the unique mathematical capacity to curve and organize abstract thoughts. The mind requires raw material to populate this architecture. It receives this material as external sensory signals, which arrive as flat, two-dimensional surfaces. Through a specific process called isometric immersion, the mind mathematically maps these incoming flat surfaces. The 2D planes contort and wrap perfectly along the complex curvature of the internal 3D manifold. This immersion is not a singular event. It is a continuous, automatic sequence, constructing a stable state of self moment by discrete moment. Subjective experience relies entirely on this active geometric control mechanism, embedding the external world into an internal topological space. The mechanical viability of this continuous embedding is proven by the Labori-Lie theorems. These recent mathematical proofs establish the exact boundary conditions under which a surface can be isometrically immersed into a three-dimensional manifold. The first condition of the theorem requires a degenerate elliptic isometric immersion. This dictates that the embedding process must perfectly preserve distances as the external signal enters the internal space. The second condition accounts for signal uncertainty by testing epsilon elliptic immersions. This step slightly perturbs the metric to calculate how the mapping responds to physical noise. This perturbation forces an analysis of the principal curvatures. Principal curvatures measure the maximum and minimum bending of a surface at a specific point, and they change dynamically as the perturbation parameter shrinks towards zero. By satisfying these conditions, the theorem mathematically links the intrinsic curvature of the incoming two-dimensional sensory signal directly to the extrinsic curvature of the mind's manifold. These strict mathematical bounds dictate exactly how surfaces can bend and fold. The geometry acts as a cognitive filter, limiting the possible shapes and thoughts that can exist within our mental space. The Labori-Lee proofs confirm that our internal representation of reality operates under absolute geometric boundaries, bypassing biological constraints entirely. Geometry dictates the space where consciousness resides, but algebra provides the action that brings the observer into existence. To calculate the complex, multidimensional actions required, we use quaternions. Quaternions are a four-dimensional complex number system, specifically designed to compute abstract spatial rotations. This diagram maps the baseline state of the universe before an observer exists. It is a purely real scalar value, represented here by the equation Q equals A. This baseline scalar state is reality zero. It represents pure, unobserved potential energy, entirely devoid of a reference frame. Within reality zero, there is no subject to observe an object. The system is totally unified, leaving the universe completely blind to itself. A stable unified state cannot spontaneously observe itself. The system requires a violent mathematical phase transition to separate the observer from the background. Pure real existence fractures. This algebraic split creates the precise dimensional distance required for an observer to emerge. The specific mathematical trigger responsible for fracturing reality zero is the I operator. This animation models the defining equation, I of Q equals Q multiplied by I. By multiplying the scalar value, the operator forces the system off its baseline. This calculation executes a Quaternionian I rotation. The system violently rotates exactly 90 degrees away from the purely real axis. The system now possesses a minimal imaginary component. Its mathematical state transitions from Q equals A to Q equals A plus BI. The real component, A, remains the core of physical potential. The new imaginary component, BI, establishes the defining boundary of the self. The formation of this new algebraic boundary is the exact mathematical origin of the subject-object division. By generating this internal geometric distance, the system gains the necessary vantage point to look back and observe its own original scalar state. The application of the I operator marks the exact mathematical moment physical reality separates into an observer and the observed. A quaternionic rotation into self-reference is not random. The system naturally seeks stability by locking into specific mathematical attractors. We locate these attractors using prime harmonics. Prime harmonics are specific, irreducible rotational states in quaternionic space, indexed strictly by prime numbers. This graph tracks the tipping point tensor. While the baseline remains flat, we see violent resonance spikes at prime intervals, 2, 3, 5, and 7. Isolating the massive spike at p equals 7 reveals the critical threshold required for stable self-reference. This p equals 7 harmonic maps directly to the 7 Hz neural oscillation observed in the human brain. This is the I am phase. A 7 Hz frequency is a topological phase transition, marking the exact rotational angle where a system achieves the geometric coherence to declare I am. Consciousness emerges when the algebraic rotation of the I operator forces the geometric immersion of physical reality into a Riemannian manifold. Awareness is a mathematically necessary projection. It is the universe observing itself, constrained and defined entirely by the absolute laws of geometry.